Hello everyone, this is Klotungan, working as Assistant Professor in ECE Department, Government College of Engineering, Tanjavur. Welcome to the video on Telecommunication Network Management. With this video, we shall have an overview of introduction about SNMPv3. The version 1 and version 2 having some drawbacks. That drawbacks we are going to be overcome here with the help of version 3. What is the main drawback in between the version 1, 2 and 3 means 1 and 2 we are not going to concentrate that security purpose. Version 3 fully concentrate that what encryption and security purpose. It is nothing but authentication is much more compared to that version 1 and version 2. Next, SNMP v3 architecture. Similar like v1 and v2, v3 also having the same setup and having the extra things we are going to be covered in that version 3 architecture with the help of title and elements of an entity, names and abstract service interfaces. With the help of 3, we are going to be explain that architecture in detail. Then version 3 applications. In this applications layer module, we are going to be discuss that 5 different topics, subclassification. First one, command generator. Second one, command responder. Third one, notification originator. Fourth one, notification receiver. And fifth one, proxy forwarder. These are all the 5 things we are going to be discussed in that application area. Then in SNMP version 3 also we are going to see the same kind of information database under the title of management information base. It's all common for all the version of version 1, version 2 and version 3. Then finally security. What's the difference? Major difference compared to the other version. How they are going to concentrate, what are all the titles we are going to be see under the points of security. That's all about overview. Introduction about v1, v2 and v3 here in a simple thing. In v1 having that security and performance problem, it's a limitation or drawback. If you concentrate that v2, SNMP v2, it's aimed to resolve the issues, above issues like performance and security, but it's not possible that much in that version 2. The most performance problems were solved, but SNMP version 2 uses community-based security methods. Same like version 1. Version 1 and version 2 uses that same community-based security methods. It's not that much sufficient, so that we simply move and improve the security solution with the help of third version. It is nothing but SNMP version 3. It provides the security solution. Moreover, modularizations of documents and architecture, SNMP engine. SNMP engine, it is nothing but architecture checks whether a specific type of access, it is nothing but the access, read, write, create and notify to a particular object or instance is allowed. That's the difference between v2 and v3. And moreover, what we are going to be perform in that version 3, it is nothing but design goals. What are the goals we are going to be achieve here with the help of address the need for security set support, first one. And second one, define an architecture to allow longevity of SNMP. It is nothing but future extensions. Third one, keep SNMP as simple as possible. Allow for minimal implementation. And fourth goal, support also more complex features which are required in large networks. Final point, it is possible to reuse existing specifications whenever possible. These are all the goals we are going to be achieved with the help of version 3. And here I am going to give that small key features, extra features about SNMP version 3. First point, one of the key features, main thing is the modularization of architecture and documentation. It's possible. And second one, the design of the architecture integrated both version 1 and version 2 specification with the newly proposed SNMP version 3. And third point, this enables continued usage of legacy SNMP entities along with version 3 agents and manager. This is the good news, as there are thousands of SNMP version 1 and SNMP version 2 agents in the field. That's a major difference. And main command, main block, it is nothing but SNMP engine. Here we are going to use is defined with explicit subsystem that include dispatch and message processing functions. That's the main function of SNMP engine. Here it manages all three versions of SNMP to coexist in a management entity, and application, services and primitives have been explicitly defined in SNMP version 3. This formalizes the various messages that have been in use in the early versions. It is nothing but version 1 and version 2. An important and another key feature is the improved security features. The configuration can be set remotely with secured communication that protects against modification of information and masquerade by using encryption schemes. And it also tries to ensure against malicious commands modification of messages by re-recording and time delaying of message streams, as well as protects against eavesdropping of messages. These are all the drawbacks we are going to be overcome with the help of version 3. It is nothing but more security authentication and security. Then the access policy used in version 1 and version 2 is continued and formalized in the access control in version 3, also designated by VACM. So this SNMP engine defined in the architecture checks whether a specific type of access, already mentioned, read, write, create, notify to a particular object or instance is allowed. Same thing I repeated here. These are all the keys of key features of version 3. Then now we are going to enter that architecture, SNMP version 3 architecture. Here the same, like it's similar like SNMP version 1 and SNMP version 2. Architecture is distributed integrating collections of version 3 entities. Then SNMP entity implements a portion of the SNMP capabilities like manager capabilities and agent capabilities. It acts as both agent or manager or both, anything, and a collection of modules interacting with each other to provide services and capabilities. These are all the architecture we are going to see with the help of three different classification, three different titles. It is nothing but elements of an entity, names and abstract service interfaces. Next slide onwards, we are going to see in detail about the three titles: entity, names and abstract service interfaces. Now, before going to the three different sub-classification titles, you want to know that what are all the advantages of SNMPv3 architecture. The role of SNMP entity is determined by the modules implemented in that entity. Certain set of modules are required for agent, while a different set is required for a manager itself. Then application specific entities can be implemented. And final advantage, security subsystem provides services such as authentication and privacy of messages. Two different one, multiple security models can coexist, and last one, new security algorithms can be integrated in that version 3 architecture, right? Then move to the, let's start with the classification of one of the thing, elements of an entity. The elements of the architecture associated with the SNMP entity in the below diagram, you can see that. the compromise an SNMP engine and a set of applications. So the SNMP engine, named SNMP engine ID, comprises a dispatcher, message processing subsystem, security subsystem, and an access control subsystem. These are all the things, terms, blocks going to be present under by SNMP engine. So in detail about SNMP engine, small introduction. From that diagram, below diagram, we simply follow that SNMP entity has one SNMP engine which is uniquely identified by an SNMP engine ID. SNMP engine ID is made up of octet strings. The length of the ID is 12 octets for version 1 and version 2, and here is variable for SNMPv3. From the diagram you can understand that first 4 octets is both formats are set to the binary equivalent of the agent's SNMP management private enterprise number. The first bit of the 4 octet is set to 1 for version 3 and 0 for earlier versions. For example, Acme Networks has been assigned the first 4 octets would read 80000 in hexa in version 3. Remaining all simply drop the 8, remaining 5 zeros to be 8 in version 1 and version 2. That's the differences. The fifth octets of SNMP version 1 and version 2 indicates the method that the enterprise used for driving the SNMP engine ID, and 6 to 12 octets function of the method. For a simple entity, it could be just the IP address of the entity. So the fifth octet of the SNMP version 3 engine ID indicates the format used in the rest of the variable number of octets. Then dispatch subsystem. Under this heading, there is only one dispatcher is in an SNMP engine, and it can handle multiple versions of SNMP messages. It does the following 3 sets of function. The first function, it sends message and receive messages from the network. The second one, it determines the version of the message and interacts with the corresponding MPM. And third one, it provides an abstract interfaces to SNMP application to deliver an incoming PDU to the local application and send a PDU from the local application to a remote entity. That's all about 3 things. The 3 separate functions in the dispatcher subsystem are accomplished using first one transport mapper, second one message dispatcher, and third one PDU dispatcher. The transport mapper delivers the message over the appropriate transport protocol of the network. The message dispatcher routes the outgoing and incoming message to the appropriate module of the message processor. Suppose if a message is received for an SNMP version which is not handled by the message processing subsystem. This is dispatch subsystem. Then message processing subsystem. Same like last one, the SNMP message processing subsystem of an SNMP engine interact with the dispatcher to handle version specific SNMP messages. Then second point, it contains one or more MPMs. The versions is identified by the version field in the headers. Then security and access control subsystem. The security subsystem provides security services at the message level in terms of authentication and privacy protection. The access control subsystem provides access authorization service. Then last one, applications module. The application module is made up of one or more applications which comprise command generator, notification receiver, proxy forwarder, command responder, and notification originator. The first three applications are normally associated with an SNMP manager and the last two things with an SNMP agent. First three SNMP manager, last two SNMP agent. The application modules may also include other applications as indicated by the box other. Then move to the major classification of names under the architecture title. Names. Naming of entities, identities, and management information is part of version 3 specification. We already mentioned the naming of an entity by its SNMP engine ID, SNMP engine ID in small letter, right? The two names are associated with identities, principal, and security name. Now, principal is the who requesting services. It could be a person or an application. So the security name is a human readable string representing a principal. The principal could be a single user. For example, name a network manager or a group of users, such as name of operator in the network operations center. It is made not accessible. It is hidden and is based on the security model used. However, it is administratively given a security name, for example, user1 or admin, which is made readable by all. That's a very important one. Then the management entity can be responsible for more than one managed object. Hope you are clear with the example. A management agent associated with a managed object at a given node could be managing a neighboring node besides its own. So each object is termed context and has a context engine ID and a context name. When there is a one-to-one relationship between the management entity and the managed object, context engine ID is the same as SNMP engine ID. Both are same. So a scoped PDU is a block of data containing context engine ID, a context name, and a PDU. Right? These are all the commands with the help of names. Then abstract service interfaces is the last block of the architecture. In this subsystem, in an SNMP entity communicate with each other across an interface, a subsystem providing a service and other using the service. We can define a service interface between the two if the interface is defined such as it is generic and independent of specific implementation. It becomes a conceptual interface termed abstract service interface. Now, these abstract services are defined by a set of primitives that define the service. It shows a subsystem is sending a request for service using the primitive AB to subsystem B. That primitive AB is associated with the receiving subsystem B, which is one of the that is providing the service in this illustration. In general, except for dispatcher primitives are associated with the receiving subsystem, the dispatcher primitives are used in receiving messages from and to the application modes, as well as registering and unregistering them and in transmitting and receiving messages from the network. So example of the application command generator sending a request and PDU to the dispatcher. So dispatcher after successful execution of the service requesting and send it into the network. Now SNMP version 3 applications. In this version 3 applications formally defines that 5 types of application. These are all not the same as a functional modes that the OSI model addresses. This may be considered as a application service elements that are used to build application. What are all that means? They are command generator, command responder, notification originator, notification receiver, and proxy forwarder. Next highlights we will discuss them briefly in detail. Command generator, first one, under the heading of application. It presents the role of the command generator when the get response message is received from the remote entity. The dispatcher service receives the message from the network and requests NPM to prepare data elements. From the diagram, you can understand that the SM validates the authenticity and privacy parameters. The dispatcher receives the return message from SM and forwards it to the command generator to process that response, particular response. For example, command generator transaction is an version 1 get request command from a network management system NMS to an agent requesting the value of system group. The command generator sends a command and OIDs, object identifiers, to the dispatcher along with version number and security information. It also sends a tracking ID, SNMPv3 handle to the NMS. This would be request ID from the diagram when the NPM returns outgoing message, which could be secured message. Secured, it is nothing but authenticated and encrypted. The dispatcher delivers it to the network using user datagram protocol UDP to the transmitter to the agent. The command generator receives the response from the dispatcher sent by the agent. So primitive process response PDU would deliver the PDU contains the value for the system group in that side diagram to the commander agent. So the commander agent matches the response PDU received with request ID with one that was sent. This is the process going to be happen in that command generator. Next, command responder. In that command responder, simply process the get and set requests destined for read and is received from a legitimate non-authoritative remote entity. It's a function. It performs the appropriate action to get or set on the network elements, prepares a get response message, and it's to be a remote entity that made the request. From the diagram, it's clear. In contrast to the diagram in which the top and bottom of processes run on two remote objects, the top and bottom of figures below to the same objects. Typically, command responder is in the management agent associated with the management objects. Two things, right? Before the get request could be processed by the command responder application, the context that the SNMP engine is responsible for must register with the SNMP engine. It does by the using of register context engine ID. Once this is in place, the get request, for example, same example as used in the command generator, is received by the dispatcher. Data elements are prepared by the NPM. Security parameters are valid by the SM and the process PDU is passed on to the command responder. This set of process going to be happening in that command responder. Once the request is processed by the command responder, it prepares the get response message. The message is passed to the dispatcher. Simply follow the diagram. The message is passed to the dispatcher using the return response PDU. So the NPM prepares the response message, the SM performs the security function, and the dispatcher eventually transmits the great response message on the whole networks. Then the command generated, the dispatcher in the SNMP agent receives the message. The message is processed by the NPM and the SM and is returned to the dispatcher. Assuming that the managed object has registered its context engine ID with the dispatcher using register context engine ID. So the message is delivered to the command responder process PDU using process PDU when the command responder acquires the system group information. It is used by the command generator to deliver the message to the dispatcher, right? This is the command responder. Then notification originator. The name itself, the application generates either a trap or an inform message. Its function is somewhat similar to the same command responder, except that is need to find out where to send the message and what SNMP version and security parameters we are going to use. Further, the notification generator must determine the context engine ID and context name of the context that has been information to be sent to the particular thing. Then particular data's newly created MIB for the notification group and the target group, as well as using other module in the system. We will learn about the new MIB, define the new groups. The notification groups contains information on whether a notification should be sent to a target, and if so, what filtering should be used on the information. Finally, the target that the notification should be sent to is obtained from the target group. That is notification originator. Then notification receiver. From the name, it receives SNMP notification messages first thing, and it registers with the SNMP engine for receiving that information messages, just as a command responder does to receive get and set messages. Then proxy forwarder. In that application, proxy forwarder performs a function similar to what we discussed on the proxy server. However, proxy definition has been clearly defined and restricted in version 3 specification. The term proxy is used to refer to a proxy forwarder application that forwards SNMP request, notification, and response without regard for what managed objects are contained in those messages. Non-SNMP object translation does not fall under this category. Okay, that category different. The proxy forwarder handles 4 types of messages. The message generated by first one, messages generated by the command generator, command responder, notification generator, and last one, those that contains a report indicator. So the proxy forwarder uses the translation table in the proxy group MIB created for those purpose. Then the different topic, it is nothing but SNMP version 3 management information base. Both are all the MIB should be same for S1, V1, V2 and V3, but the information should be different. The new objects defined in version 3 follow the textual convention specified in version 2 and described in this section. We will address a subset of the MIB here. From that diagram, new object group, they are nodes under SNMP nodes 1.3.6.1.6.3 from the diagram, right? There are 7 new MIB groups. In that SNMP framework MIB node 10 under SNMP modules describe the SNMP management architecture. That MIB group SNMP MDP MIP nodes identifies that objects in message processing and dispatching subsystem. These are all the 3 groups defined under SNMP modules for application. There are SNMP target MIP node 12 and node 13 and node 14. These are all the things. The first 2 are used for notification generator, remaining 2 are MIB objects, which are used to remotely configure the parameters used by the module SNMP entity. There are 2 tables in that MIB which are specific interest for us. In the diagram, SNMP target address table, which is an SNMP target objects group, contains the address to be used in the generation of SNMP messages. Then the last topic of that, version 3, SNMP version 3, it is very important because it's entirely different from version 1 and version 2. It is nothing but security. One of the main objectives, if not the main objective in developing version 3, is the addition of security features to SNMP management. Simply I am giving the intro for security. Then authentication and privacy of information, as well as authentication and access control, have been described in version 3 specification. It's not available in version 1 and version 2. We will cover the authentication and privacy issues in this section. We will deal with access control, and version 3 architecture permits flexibility to use any protocol for authentication and privacy of information. However, version 3 working group are specified a USM for each security subsystem. It is termed as user based as it follows the traditional concept of a user identified by the user name with which to associate security information. We will discuss the general aspects of security associated with the types of threats, security modules, the message data format to accommodate security parameters, and the use and management keys in the below section. In the under that, classification types or blocks in the 3 heading. First one, security threat, then security model, and then message format. In then security threats, how we are going to be identified that with the help of modification and masquerade. Under the heading of security model, having the 4 subclassification: authoritative, SNMP engine, security authentication, privacy of information, and timeliness of message. Finally, message format. One by one we are going to see here. First one, security threats. The 4 types of threats exist to network managed information while it is being transported from one management entity to another. What are all that? First type, modification of information. Second one, masquerade. Third one, message stream modification. And fourth one, disclosure. All right, where the information is transported from management entity A to management entity B. For these first three traits, the signal has to be intercepted by an intruder to tamper with it, where areas for the disclosure threat, the signal can just be tapped and not intercepted. It is nothing but security threats. In that security threats, first one, modification. Modification of information is a threat that some unauthorized user may modify the contents of the message while it is in transit. So data contents are modified, including falsifying the value of an object. It does not include the changes the originating or destination address. So modified message is received by the entity B, which is unaware that it has been modified. Simple example, the response by an SNMP agent to a request by an SNMP manager could be altered by this trait. It's also possible. It is nothing but modification. Then masquerade is when of the unauthorized user sends information to another assuming the identifying of an unauthorized user. That is masquerade. This can be done by changing the originating address. It's only possible. Using the masquerade and modification of information, an unauthorized user can perform operation on a management entity which he or she is not permitted to do. So SNMP set operation should be protected against this attack. It is security threats. It is nothing but security threats. Then the fourth and last threat, the message need not be intercepted for this, but just a waste drop. For example, message stream of accounting could be promiscuously monitored by an employee with a layer of TCP IP dump procedure, and then the information could be used against the establishment. So the second and the threat considered as a management threat is traffic analysis by an unauthorized user. It was determined by the version 3 working group that there is no significant advantage achieved by protecting against this attack. Then next classification, next one in that security is nothing but security model. In normal operation procedure, MPM is the message processing subsystem interacts with security subsystem models. For example, ongoing messages is generated by the application, which is first handled by the dispatcher subsystem, then by an MPM, and finally by the SM. This is the continuation and procedure. If the message is to be authenticated, the SM authenticates it and forwards it to the NPM. Similarly, for an incoming message, the NPM requests the service of the security subsystem to authenticate the user ID. In that security model, the authoritative SNMP engine we are going to be discussed with two management entities communicate. The service provided by each and determined by the role they play. That is, wherever whether the entity is authorized to perform the service, this lead to the concept of authoritative and non-authoritative SNMP engines. This is dependent on which SNMP engine controls the communication between the two entities. So version 3 architecture defines that in a communication between two SNMP engines, one acts as an authoritative engine and the other as a non-authoritative engine. There is a well-defined set of rules as to who is authoritative SNMP engine for each message that is communicated between two engines. For example, get request, get next request, get bulk request, set request, or inform messages. The receiver of the messages is the authoritative SNMP engine. Since these above messages are originated by a manager process in a network management system, the receiver is the SNMP agent. So the agent is the authoritative engine for trap, get response, and report messages. The sender or the agent is the authoritative SNMP engine. Thus, an SNMP engine that acts in the role of an agent is designated authoritative SNMP engine. So that engine act in the role of the manager is the non-authoritative engine. In general, the agent is the non-authoritative engine in SNMP communication. So SNMP agent is the authoritative engine, right? Then security authentication. The communication between two entities could satisfy the condition of authoritative and non-authoritative pair. However, it should be the right set of pairs. The source from which the message is received should be authenticated by the receiver. Further authentication is needed for the security reasons. Security authentications is done by the authentication module in the security subsystem, right? That authentication modules provides two services, one data integrity and second one data origin authentication. The data integrity, it is nothing but the service provides the function of authenticating a message at the originating end and validating it at the receiving end. Authentication validation also catches any non-malicious modification of data in the communication channel. The second service is provided by the authentication module is data origin authentication. These ensure that the claimed identity of the user on whose behalf the message was sent is truly the originator of the message. These are the two services of data integrity and data origin authentication. Then privacy of information. The second third model, which provides the data confidentiality service. It is nothing but Data confidentiality ensures that information is made available or disclosed to unauthorized users, entity, or process. It is a use of privacy of information. So the privacy of the message is accomplished by encrypting the message at the sending end and decrypting at the receiving end. This is the process of privacy of information. Then last one, timeliness of message. Timeliness of message is a module of security subsystem that provides a function of checking message timelines and thus prevents message redirection or delay or replay. Simply we are going to avoid this all those things, redirection, delay, or replay. Using this concept of an unauthoritative SNMP engine, a window of time is set in the receiver to accept a message. The travel time between that sender and the receiver should be within this time window interval. The time clock in both the sender and receiver is synchronized with SNMP engine. So the recommended window time for version 3 is 150 seconds only. For implementation of the timeliness module, the engine maintains 3 objects. What are all the 3 objects? Means SNMP engine ID, SNMP engine boards, and finally SNMP engine time. You know that first one, SNMP engine ID uniquely identifies that authoritative SNMP engine. Second one, SNMP engine boots that count of the number of times of engine has rebooted or reinitialized. And third one, SNMP engine time is the number of seconds since the SNMP engine boots counter was last initialized or reset. With the help of 3, we are going to be implement that timeliness of engine message or module. Last one in that security is nothing but message format. It's very important. It consists of 4 groups of data. Details of the field in each group with just version number and in the same positions as in version 1 and version 2. First one, global header, global data, defined by the data type header and the signed group of data in the message format. They contain administrative parameter of the message, which are message ID, message maximum size, message flag, and fourth one, last one, message SN. It is worth nothing noting that an SNMP engine can handle many modules concurrently in the message processing subsystem. The dispatcher subsystem examines the version number in the message and sends it to appropriate message processing the module in the message subsystem. Small example, in this version is set version 2, messages processing module would be invoked. The third group of data security parameters are used by the SM in communication between sending and receiving entities. The value of the parameters it fully depends upon that message SM in the header data. That's all. Thank you.